Imagine you're a teacher sitting at your kitchen table, right? And you're staring at a student's essay that just feels, well, a little too perfect.
Oh, yeah. Every teacher knows that feeling by now.
Right. And for the last couple of years, you've probably relied on those clunky third-party AI detectors to guess if a student cheated. Running the text through a scanner that basically just looks for how often the writer uses the word delve or quietly.
Yeah, those old scanners, they're everywhere.
Exactly. But as of mid-2026, that entire guessing game is, well, it's effectively becoming obsolete because artificial intelligence is now hiding an invisible cryptographic fingerprint inside the actual spaces between the words.
It really is a profound shift. I mean, we're looking at an August 14th, 2026 announcement from Anthropic, and it details exactly how Claude's text watermarking functions.
And this matters for, like, everyone, right?
Oh, absolutely. For anyone listening who uses AI, whether you're a developer generating complex code or a manager drafting quarterly emails or, just someone poking around out of sheer curiosity, the language you're reading now carries a verifiable mathematical signature.
Okay, let's unpack this. Because framing this as just a routine software update or like some dense terms of service change really doesn't do it justice.
No, it really doesn't.
It's this fascinating peek right under the hood of how language models actually think, how they construct reality. And to understand how you can hide a fingerprint in plain text without anyone seeing it, we really need to strip away the magic.
Right. We need to look at how an AI actually chooses its words in the first place, because most people still intuitively feel like an AI writes the way a human does.
Yeah, like it has an idea and then just types it out.
Exactly. But when we speak, we generally hold a complete thought or, an entire sentence in our heads before we start vocalizing it. But large language models or LLMs, they do not do that at all.
I just fake it really well.
Right. They operate strictly on the illusion of choice. They generate text sequentially, just one single word, or, well, more accurately, one token at a time. It is a system built entirely on probabilities.
It's basically the world's most hyper-advanced version of the autocomplete on your phone.
That is a perfect way to describe it.
And the source material provided a really clean, simple example of this mechanism. So let's say the AI is in the middle of writing a sentence, and it outputs, "The weather today was cold," and then it just pauses.
Right. It hits that blank space.
Yeah. The system pauses at that blank space, and it now has to calculate the probability of what the very next word should be. Obviously, the word sugary is going to have a near zero probability. I mean, it makes no sense.
No, cold and sugary weather is not really a thing.
Exactly. But words like overcast or gray, those are both extremely sensible, highly probable choices, right?
Yes. And in a standard unwatermarked system, when the AI evaluates that list of probabilities and finds two or more equally good choices, like overcast and gray, it essentially just rolls a digital die.
It just guesses.
Pretty much. It relies on a standard random number generator to pick one, because as a reader, it makes absolutely no difference to you whether the AI lands on overcast or gray. The core meaning of the sentence remains completely intact.
So it doesn't matter which one it picks.
Right. Engineers refer to these as low-stakes choices. The text needs a word, multiple words work perfectly, so it just flips a coin.
And that standard coin flip is where the watermark steps in, right?
Exactly. When this new system is activated, Claude stops using that generic random number generator. Instead, it introduces a specific cryptographic key.
A cryptographic key. Sounds intense.
It's just a unique string of data, really, and it combines that key with the immediate sequence of words that came just before the blank space to finalize the decision. Think of it as a highly complex, secret mathematical filter held internally by Anthropic.
So wait, when it needs to make that choice between overcast and gray, it runs the previous words through this secret filter.
Yep. The math dictates the choice now, rather than pure chaotic randomness.
Wait, hold on. If you're taking away the random dice roll and replacing it with a fixed mathematical key, doesn't that just turn Claude into a broken record?
Nodding.
Like, aren't we basically rigging it to be repetitive? If the key forces a choice, won't it eventually run out of normal words and start forcing weird vocabulary just to satisfy the math?
Ah, I see what you're saying. But what's fascinating here is that the underlying vocabulary pool isn't altered at all. The choices the model is considering are still completely natural.
So it won't start sounding like a thesaurus.
No, definitely not. The watermark mechanism does not have the power to inject a bizarre, obscure word like nubilis into the sentence just because it needs a mathematical match.
Nubilis, is that even a word?
It's an obscure synonym for overcast. But the point is, if Claude wouldn't naturally use the word nubilus under normal circumstances, it is absolutely not going to use it now. The pool of highly probable choices remains the exact same.
Okay, so the options are normal. It's just how it picks from those options that changes.
Right. The only thing that has shifted is the origin of the selection. It might pick overcast in one paragraph and gray in another, strictly depending on the unique sequence of words that led up to that exact moment.
Okay, let me make sure I'm wrapping my head around this. From my perspective, like as the user sitting at the keyboard, the words still feel entirely random and conversational.
Really natural, yeah.
But if I happen to possess that secret cryptographic key, I can look at the final essay and mathematically verify if the sequence of word choices aligns perfectly with the hidden filter.
That is the entire premise. The text is watermarked by the underlying structure of the choices, and it's completely invisible to the naked eye.
I mean, I follow the mechanics of the math there, but I have to imagine anyone listening is asking the obvious question here.
Which is,
Does this lobotomize the AI? I mean, does the output get worse? If the engine is constantly worrying about satisfying a secret cryptographic key, does the writing get clunky?
it is the most common fear when this technology is discussed, frankly. But the empirical data tells a completely different story.
Really? No drop in quality?
None. Anthropic conducted extensive internal testing on live traffic. And more importantly, this specific watermarking architecture is based heavily on Google DeepMind's 2024 SynthID-Text paper, which was published in the journal Nature.
Oh, wow. So there's serious peer-reviewed science behind this.
Absolutely. They subjected a watermarked model and an unwatermarked model to millions of real-world interactions. They measured thumbs-up and thumbs-down ratings from blind users. They tracked creativity, readability, server speed, compute cost, all of it.
And the result was?
What? Zero statistical difference.
Zero. That's wild.
Across the board, human raters cannot detect any drop in quality or change in tone. The watermarked responses were completely indistinguishable from the baseline model.
I mean, zero statistical difference is a massive engineering achievement when you consider that the math is literally constantly manipulating the vocabulary.
It really is. To visualize how you can manipulate an outcome without anyone noticing, the source material offers this brilliant analogy involving a board game.
Okay, let's hear it.
Imagine you and your friends sit down to play a game of Monopoly. Under normal rules, every time it is your turn, you roll a pair of plastic dice to generate a random number of spaces to move.
Right. Pretty standard.
Now imagine that before the game starts, I secretly swap out those dice for a thick book containing the digits of pi.
Wait, the digits of pi, like the mathematical constant, 3.14159, and so on, forever.
Yes. We open the book to a random starting point, let's say the 1 millionth digit after the decimal place, which happens to be a 6.
Okay, I'm with you.
From that moment forward, instead of rolling the plastic dice, every player just uses the very next digit of pi in the sequence for their move. The first player moves 6 spaces. The next digit is a 5, so the next player moves 5 spaces, then 3, then 8, and so on.
Oh, I get it. To the people sitting around the board just drinking soda and buying properties, the game feels completely normal.
Exactly. The moves feel entirely unpredictable. The players have no idea the randomness has been replaced.
Because the numbers are all jumbled anyway.
Right. The game doesn't break, nobody is forced into an impossible move, and the evening proceeds perfectly. But if an observer walks into the room after the game is finished, and that observer happens to know we were using the sequence of pi starting at that specific digit,
They can track it.
yes, they can look at the history of everyone's moves and mathematically verify the pattern. They can say with absolute certainty, this specific sequence of moves matches the hidden structure of pi.
Because the game was watermarked by the math. That's brilliant.
It's a great analogy, right?
So it's basically like a magician dealing from a loaded deck of cards. To the volunteer pulling the card out of the deck, the choice feels like pure, unadulterated luck.
They think they could have pulled any card.
Exactly. But the dealer knows the exact sequence of the deck. They know the underlying structure of the trick.
The dealer holds the key while the player just enjoys the game. The text you receive from Claude feels like a natural, spontaneous draw from the deck of language. But the underlying sequence of those draws is verifiable to the system that holds the cryptographic key.
But wait. Your Monopoly trick assumes there are multiple places I can actually move on the board, and my magician trick assumes there are multiple cards I could possibly pull.
Okay, I see where you're going.
What happens when there is only one correct answer? If the stakes aren't low, how can Claude possibly use a math trick to pick a word without just hallucinating a completely wrong answer.
If we connect this to the bigger picture, you are hitting on the fundamental boundary of where this entire technology struggles.
Ah, so there is a catch.
A big one.
There you go.
Because the watermark mechanism relies entirely on the luxury of swapping out interchangeable words, it fundamentally fails, or it becomes incredibly sparse in rigid, factual scenarios. Accuracy always overrides the watermark nudge.
Let's walk through a real-world scenario of that. Let's say I ask Claude a direct historical question, like I need a specific fact.
Okay, so if you prompt the AI to complete the sentence Isaac Newton's most famous mathematical work was called, it must end that sentence with Principia Mathematica.
Right. There is no alternate choice there.
None. It cannot consult a cryptographic key and randomly decide to swap in a synonym because there are no synonyms for the title of that book. Since there is zero generative choice to be made, the watermark has absolutely nothing to act on.
So the invisible fingerprint just skips that part of the text entirely.
Exactly. It just passes right over it.
Okay, that makes perfect sense for historical facts.
Eh.
But what about logic structures, like math or coding? I imagine a developer writing a Python script doesn't want the AI swapping out variables just to satisfy a hidden mathematical filter.
Oh, the exact same principle applies there. The statement 2 + 2 = must be followed by 4.
Yeah, you definitely don't want a synonym for 4 in your math homework.
Right. And in strict software development, replacing a single syntactic term or variable will literally break the entire application. So the watermark is not applied to those rigid tokens.
It just leaves the code alone completely.
Pretty much. It might attach itself to the conversational plain English comments that the AI writes between the lines of code, where language is flexible, but it will never touch the rigid syntax of the code itself.
Okay, what if I'm not asking it to write something new at all? What if I write a 3-page email myself, paste it into the prompt box, and just ask Claude to proofread it and fix my comma splices?
In that scenario, the vast majority of the words are already yours. Claude is making very few generative decisions.
Because it's mostly just retaining my original text.
Exactly. Fewer decisions mean fewer opportunities for the watermark to attach itself to the output.
So if I'm a student trying to cheat on a history paper by having Claude write an essay packed with strict historical dates and titles, or if I'm a developer writing strict code, this watermark is practically useless.
Basically, yes. The facts dictate the words.
Wow, that's a huge blind spot.
It's a limitation for sure. The confidence level of the detection API scales strictly with length and generative flexibility. If you ask the model for a short, highly factual, rigidly constrained response, the resulting watermark will be incredibly weak, if it exists at all.
But if I ask for a 5-page essay on, like, abstract poetry?
Then there is massive flexibility in how those concepts can be described. The more creative choices the model is forced to make, the stronger, more dense, and more detectable the cryptographic watermark becomes.
Okay, so if this watermark is quietly tracking these flexible word choices across millions of prompts, drafting emails and essays for users all over the world, my immediate thought goes straight to privacy.
As it should.
Right, like who holds the key to this massive database of mathematical fingerprints, and what does it mean for the person sitting at the keyboard?
The privacy implications are definitely the most critical part of this rollout. And to understand the boundaries, we first need to look at the catalyst. Anthropic didn't just wake up one morning and decide to overhaul their entire foundational architecture for the fun of it.
I assumed there was some pressure from somewhere.
Huge pressure. They, alongside roughly 190 other major artificial intelligence providers, are signatories to the EU Code of Practice on transparency of AI-generated content.
Ah, the EU. They're always ahead on tech regulation.
Yes. This massive shift is happening to comply with the European Union AI Act, which officially required AI marking capabilities as of August 2, 2026.
Okay, so this is a legal compliance mandate dictating the technology.
Yeah.
But the EU is just one region. Why is an American user or, an Asian user seeing this applied to their prompts?
Because building durable, region-specific architecture that perfectly scopes out who is and isn't subject to the law is incredibly difficult. It's a logistical nightmare.
So it's easier to just watermark everybody.
Pretty much. Rather than risk compliance failures, Anthropic is rolling this text watermark out globally to all users, but they are incredibly explicit about the privacy guarantees attached to it.
Okay, what are the guarantees?
The text watermark is entirely anonymous. It cannot, under any circumstances, be traced back to a specific user account. It cannot be traced to a specific organization.
Not even to a specific chat log.
Not even a chat log. The key only looks at the mathematical probability of the word choices in a vacuum. It holds absolutely zero user data.
Okay, well, that covers the text generation. But Claude is multimodal now. It generates images, it processes files, it creates SVGs.
Right, it does a lot more than just text.
So if the text watermark is hidden in the spaces between the words, is Anthropic burying a cryptographic key in the actual pixels of an image, like digital steganography?
No, no. And it is vital to separate how Claude handles text from how it handles images. They use completely different mechanisms. For images and files, Claude relies on an open industry standard known as C2PA.
Okay, C2PA, break that down for me. What is that?
It stands for the Coalition for Content Provenance and Authenticity. It is the exact same standard currently used by major camera manufacturers to verify the origin of a digital photograph.
Oh, so it's not a secret Anthropic thing. It's an industry standard.
Exactly. With a generated image, Claude does not hide a secret watermark inside the visual content itself. Instead, it attaches a content credential directly into the file's metadata.
For anyone listening who isn't, deep into file structures, how should we visualize metadata?
Think of metadata as the digital shipping label glued to the outside of a cardboard box.
Okay, shipping label.
The image itself is the payload inside the box. The C2PA standard is a cryptographically signed shipping label that states this specific file was generated or processed by Claude.
I like that analogy. But if it's just a shipping label on the outside of the box, what happens if I open the box, take the item out, and put it in a different box?
Well, the label doesn't move with the item.
Right, so what if I just take a screenshot of the AI-generated image on my phone rather than downloading the actual file? Does the shipping label survive?
In most cases, taking a screenshot strips the metadata entirely. The C2PA label falls off, and the provenance is lost completely.
So it's actually pretty fragile.
It is a known limitation of metadata-based tracking compared to the structural text watermarking we discussed earlier.
So what does this all mean? If the text watermark is totally anonymous, and the image metadata can just be stripped away with a screenshot, how does this actually prove anything in the real world?
That is the big question.
Right. If I am a university professor trying to determine if a student cheated, or a publisher trying to verify a manuscript, what does Anthropic's detection API actually tell me?
It is crucial to understand what the API does not do. The detection tool does not prove authorship. It does not prove copyright. It does not change who legally owns the rights to the output.
Okay, so what does it do?
The API only answers one highly specific mathematical question. What is the likelihood that Claude was involved with generating this text at some point? That is the entire scope of the answer.
Likelihood. Which means it cannot tell the difference between Claude writing an entire 10-page article completely from scratch versus Claude simply doing a heavy grammatical edit on a 10-page article that a human spent weeks writing.
It cannot distinguish between those two realities at all.
Wow.
Because both scenarios involve Claude making generative word choices, which means both scenarios will result in the cryptographic watermark being embedded in the final text. The detector will simply flag that Claude's mathematical fingerprint is present. It cannot provide the context of how it got there.
When you look at this incredibly nuanced cryptographic approach, it really highlights just how crude our legacy attempts at catching AI have been over the last few years.
Oh, you mean the older third-party AI detection software?
Yeah, exactly. Companies like Pangram and all those various scanners universities rush to adopt. Teachers and editors have been treating those third-party detectors as absolute gospel for years.
And they really shouldn't have been.
Clearly, because those external companies don't have Anthropic's secret cryptographic key. They don't have the internal math. So how are they even operating?
They operate on a completely different, much more flawed premise. Because they do not have access to the mathematical key, they have to rely on behavioral tells. They essentially scan for stylistic cliches in the phrasing.
Stylistic cliches.
Yeah, the source material points out that early AI models historically leaned heavily on specific structural habits. For example, AI loves using the construction, this isn't just X, it's Y, or they severely overuse certain transitional adverbs.
Oh my gosh, the word quietly. I see it in generated text constantly. The tech industry is quietly shifting. It is a dead giveaway.
Exactly. The legacy detectors are simply scanning the text for those stylistic stereotypes and assigning a probability based on, well, the vibes of the writing.
The vibes.
Yeah, basically. But that brings us to the reality of tampering. With Anthropic's new cryptographic watermark, light editing by a human won't break the pattern. You can change a few words here and there, and the underlying mathematical sequence is robust enough to survive.
Okay, but what if I edit a lot?
Completely rewriting the text, replacing every single word manually will destroy the watermark entirely.
Wait, hold on. Here's where it gets really interesting to me. I'm just putting this together.
Okay, what are you thinking?
The old third-party detectors are out there hunting for awkward, stereotypical AI-sounding phrases.
Hmm,
They're looking for clunky adverbs, right?
right.
But Anthropic's new watermark operates on completely invisible, entirely natural probabilities.
Yeah.
It relies on a mathematical key to pick words that flow perfectly, avoiding those bizarre robotic cliches.
Yes, that's the goal.
So, wouldn't this new mathematically watermarked text actually look less like AI to those legacy detectors? I mean, by forcing natural word choices, the actual watermark makes the text dodge the old scanners.
This raises an important question, doesn't it? It completely exposes the flaw in how we have been policing generated text. It cements the idea that true, reliable watermarking has to be structural and mathematical.
Because the stylistic stuff is just guessing.
Exactly. Stylistic detection is always going to be a futile cat-and-mouse game based on vibes and shifting vocabularies. Cryptographic watermarking relies on verifiable probabilities that don't depend on the text sounding robotic.
It is an incredible evolution in how we manage synthetic language. I mean, to quickly recap the journey we just took, we've gone from understanding how LLMs generate text one single word at a time to how a hidden cryptographic key subtly alters the source of that randomness.
Swapping our plastic Monopoly dice for the infinite digits of pi.
Yes, exactly. And we've seen how this deeply complex mathematical steering preserves the absolute quality of the text without sacrificing server speed or compute costs. But we also mapped out how it inherently fails when there's only one correct answer, like in factual history, strict code, or just light proofreading.
And it's all being driven on a global scale by the EU AI Act.
Right, pushing the industry toward an anonymous, verifiable way to at least determine the likelihood of AI involvement, moving us far away from those old, clunky scanners hunting for the word quietly.
It is a massive step towards structural transparency in a world flooded with synthetic content, even if the fingerprint itself remains entirely invisible to the naked eye.
It really is. And looking at how robust yet fragile this watermark can be, it leaves me with one final kind of philosophical thought for you to chew on.
Oh, I like a philosophical thought.
Well, we talked about how completely rewriting the output destroys the mathematical pattern, right?
Right.
So if you take a fully watermarked AI-generated essay where the ideas, the pacing, and the original structure were entirely conceived by machine, and you manually rewrite every single word with a thesaurus until the cryptographic watermark is completely obliterated.
Okay, yeah.
At what exact point does that text cease to be AI-generated and become human authorship? It's the ultimate ship of Theseus. If the core ideas belong to the algorithm, but the final visible words belong entirely to the human, who is the real author?
That is a fascinating question.
Just how deep does that invisible fingerprint really go? Something for you to ponder the next time you sit down at the keyboard and ask a language model to help you out. Thank you so much for joining us on this deep dive.